Let's continue our discussion by talking about supernova effects. So, after or during a supernova, there is a creation of much heavier elements that could be created in the core of a star. So, these heavier elements are recycled into space by the explosion, and it enriches the material, the interstellar material, the gas and dust that form new stars and planets. So, we'll have a much more diverse amount of material or diverse material that can then be created or can then be used to create new stars and planets. Now, having a supernova nearby could be devastating to life on Earth, but fortunately, there are no stars that could go supernova that are close enough to have any effects. So, this is a couple of different things that could happen if they were this close. So if they were within 50 light years, it could possibly wipe out life as we know it. If it were within 100 light years, it could cause extinctions due to radiation levels. But again, fortunately, there are no stars that could go supernova close to or close enough to have these effects on us or on Earth. And I wanted to point out a couple of observations of supernova 1987A. It is right here. We can see it. We can see there's two rings and then the protostar in the middle. This is located in the Large Magellanic Cloud. And this image is a composite of several images that were by Hubble Space Telescope in 1994, 96, and 97. So they took a bunch of images and composited them into one final image. And it has now been hypothesized or actually confirmed that the star was a blue supergiant. And here are a couple of more images from 97 to 2003. You can see the evolution that's happening in the supernova. So what is left after the supernova? The main thing is that there will be a remnant from the outer layers of the star, and then a core. So we have this material of the outer layers that kind of get pushed away, and then we have a core inside, or left behind, I should say. So it could form one of two things. It could become a neutron star or a black hole, and that is based on the mass. So if the neutron star, or it will form a neutron star if the core is less than 3 times the mass of the sun, okay? Or I can put, this will be less than, erase, less than 3 times the mass of the sun. Or it can become a black hole if it is, if the mass is greater than 3 times the mass of the sun. Okay, so there's two different cases, and there's something that was discovered by Jocelyn Bell in 1967. She found unusual radio emissions that were coming out from space, and they were very regular. These pulses were very regular in the sense that every some odd seconds, which actually turned out to be about 1.337 seconds, there was a pulse of radio emission. And she first thought maybe it was a sign of life. Because it's so regular, we could also put out a signal like that. So they called it LGM, or little green men. And it was found that it was a pulsar. So this pulsar, they just kind of noted it, and these were pulsating radio sources, and now it's understood that these were rotating magnetic neutron stars that were energetic enough to produce a detectable beam of radiation and particles. So these are what are called pulsars. Okay. Now, through all of this, again, this is a neutron star. These were detected. Um, and the neutron star is a compact core of a dead star, and the size is about the size of a city. So, like we said before, it goes from the size of about Earth all the way down to the size of a city, about 20 kilometers, we said before. So, this neutron star must be very, very dense, right? It must be extremely high in density. Okay, so this kind of concludes our discussion on the death of stars. Although next time we will talk about black holes and relativity. That's chapter 24. So stay tuned for that. Of course, I will have up some crash course videos to explain what we're talking about now. And we're going to again hit in the crash course videos the low mass and high mass stars and as they evolve. So they're going to talk a little bit. Not in depth, but kind of cover what we talked about last time as well with the evolution of those stars, and talk about their deaths as well. Okay, so stay tuned for that, and I will see you in class. Thanks.